Continuing with the AP cumulative review for multiple choice. Number 7, we're still on limits here. Let f be defined by f of x being 2x plus 3 over x plus 1. Which of the following statements are true? Okay. The graph has a horizontal asymptote at y equals 2 because the limit as x approaches infinity of f of x equals 2. So if we think about limit as x approaches infinity or negative infinity, with infinity we always compare degrees between numerator and denominator. The degrees are the same, so 2 over 1 equals 2. So limit is equal to 2. It doesn't matter if we're going to negative infinity or positive infinity, we're going to have the same asymptote on either side of the infinity. So both statements are true. The graph has a vertical asymptote at x equals -1. So we see that there is a vertical asymptote because that -1 causes the denominator to be 0. Because the limit as x approaches -1 from the right side of -1 is infinity. So if we want to do one-side limit, we can always see where that takes us. So with if I do limit as x approaches -1 from the right side of -1, remember the first thing that we do with one-side limit, don't do anything with decimals yet. Let's plug -1 in first. So if -1 goes into the expression, we get -2 plus 3, which is 1 over 0. Now that's a red flag. Now we know that, okay, the limit doesn't exist. It's not 0 over 0. It's not a real number. There must be a vertical asymptote. But we're not asking for whether the limit exists or not. We want to know how the graph is moving. So now, once we know that there's a vertical asymptote, then we look at decimals. So in this case, if we're approaching -1 from the right side of -1, that's a value that is within a tenth of that -1 from the right side is going to be -0.9. So plug -0.9 in for x. We get 2 times -0.9 plus 3. That's going to give us a positive value. -0.9 plus 1, that's also positive. So we know that once we're here, once we know that there is a vertical asymptote, there's only two options, right? It's either positive infinity or it's negative infinity. And that's when we use decimals to help us decide between these two options. So positive over positive is positive infinity. So this statement is true. So options 1, 2, and 3 are all true for number 7. Okay, number 8, let the function be f of x equals 2 to the x cubed. Selected values of f are given above. We want to approximate f prime of 0.5. What is the difference between the approximation and the actual value of f prime of 0.5? So slope, approximation of slope is just finding the closest 2 points. There's only 2 ordered pairs here, so we just find the slope here, change in y over change in x. Our slope approximation is 1. But we have an actual function that we can evaluate the derivative for, so we can use our calculator, math 8 and deriv. We can find the exact steepness of this graph, which is 0.567. And it's just asking, the problem is just asking what is the difference between the approximation and the actual value. So we just subtract these two. The difference is 1 minus 0.567, which is 0.433. All right, number 9. The graph of a trigonometric function f of x is shown, where x falls between a and b. At which of the following points could f of x be the instantaneous rate of change? So instantaneous rate of change is the exact steepness equal the average rate of change between a, b. So here between a, b, here's my average slope between the 2 points. And so which one of these points is going to have the closest to this slope? Looks like A is more of a slope 0. B, maybe it's a little bit steeper, but it's pretty close. C is definitely more negative, and D is a positive slope. So it looks like the slope at B is going to be closest to this slope between A and B. Okay, number 10. We have a piecewise function. Let the function be defined. Which of the following statements is true? All these statements are about continuity and differentiability, so let me review a couple of things about it. continuity means that the piecewise function, these piecewise functions, they must connect, right? And if they must connect, that means at 2, these graphs must be in agreement with the same y value. So if I plug 2 in here and 2 in here, they have to give me the same y values. Okay, if they doesn't, then that means obviously these two graphs are going to be disconnected. Now that will allow for continuity if these two graphs, if these two functions are equal to each other at x equals 2. Now, differentiability is something else. Differentiability is where not only do these graphs have to connect, but they have to connect in a way where at 2, there's a smooth transition with the slope. So that means the slope at 2 for this graph must be the same as the slope at 2 for this graph. So differentiability indicates that the function must share the same slope at x equals 2. That will allow for a smooth transition from one graph to the next, and there won't be a sudden sharp change in slope. So with continuity, that means we can set the two equations equal to each other and replace all the x's with 2. And with differentiability, that means we can set the two derivatives equal to each other and then solve for, and then see if they are in agreement. So with continuity statement, I'm going to set my two expressions equal to each other, replace x with 2, and see if I have the same result. Plug 2 in, I get 3 times 2 plus 1, which is 7. 5 times 2 is 10 minus 3, which is 7. 7 equals 7. So that state, we know they are going to share the same y value at 2. So this is good. This is going to pass that continuity test. Okay. Now with the derivatives, let's look at each of these derivatives here. These are both linear functions. The derivative for 3x plus 1 is just going to be 3. The derivative for 5x minus 3 is going to be 5. So this graph is always going to have, first graph will always have a slope of 3, and then suddenly it's going to transition to a graph that always has a slope of 5. So we see that there's not going to be a smooth transition from one slope to the next. Therefore, the slopes do not match. Even though the function is continuous, these two graphs connected together is not going to be differentiable. So continuous but not differentiable at x equals 2. All right, we see a limit statement. The first thing we do with limit statement, if it's approaching a real number, we just plug that number in. So 0 plugs in for all the h's. So 5e to the x minus 5e to the x plus 0 over 3 times 0. This gives us 5e to the x minus 5e to the x, which is 0. 3 times 0 is 0. So if we get 0 over 0, we know that there's a hole. We can apply L'Hopital's rule and reevaluate. Now, something to keep in mind here is h is the one that's the variable. Okay, so everything that we're finding the derivative for is with respect to h, and x in this case is going to be a constant. X is not changing. It's h that's changing. H is the one that's moving. It's approaching 0. So we got to switch gears a little bit and just understand that when we find the derivative, h is the one that's that we're finding the derivative of. And there's no h involved, that means it's a constant, and that constant will just go to 0. So let's look at each of these terms here. 5e to the x, x is just a number. There's no variable here, that's just a number, so this number's derivative is just going to be 0. Okay, the second term, 5e to the x plus h, the derivative for 5e to the x plus h, there is a variable here, so the derivative for e to the u is e to the u times u prime. So e to the u times u prime, x goes to 0, h goes to 1, the negative 5 stays. 3h, there's a h here, so the derivative for 3h is going to be 3. And now we reevaluate. So replace any remaining h with 0. We get negative 5e to the x plus 0 over 3. And that's just negative 5e to the x over 3. That's answer choice C. All right, number 12, the function f is given by f of x. We have x cubed plus bx plus 6. This is parentheses was separated from the g of x. B is a constant. G is a differentiable function satisfying g of 2 equals 3, g prime of 2 equals negative 1. Again, differentiable just means a smooth curve. For what value of b is f prime of 2 equal to 0? Okay, so a couple of things here. We're going to first have to make our way from f of x to f prime. So Here we see there's a need for product rule, so we're going to have to find f prime using product rule. After that, then we can set our derivative equal to 0, replace every x with 2, and that should lead us to allow us to solve for b. Alright, so this whole first expression is my f function, the second is my g function. We'll go through product rule, f prime g plus f g prime. So the first term here, derivative, x cubed becomes 3x squared, bx becomes b, 6 goes to 0. G function stays, f function, no changes, and then g of x derivative becomes g prime. Okay, so we have our derivative. We're going to set f prime of 2 equal to 0, so we're going to set f prime equal to 0, and we're going to replace every x with 2, so replace every x with 2. And let's see if we can work our way down to solve for b. So every x gets replaced with 2. Here 3 times 4 is 12. 12 plus b times g of 2. G of 2 we're told is 3, so we'll make that substitution. 2 cubed is 8. 8 plus 2b plus 6. Combine some like terms here. We get 8 plus 6 is 14. Plus 2b times g prime of 2 is negative 1. So now we have a bunch of parentheses here. We can distribute 12 through, the b through, we get 36 plus 3b minus, distribute the negative 1 through, so negative 14 minus 2b. Combine some more like terms here. 36 minus 14 is 22. 3b minus 2b is 1b. So now we can just solve for b. So 0 is on this side here, subtract 22 to get b by itself, so b equals negative 22.